Hey guys, in this video we're going to continue solving equations, and in particular we're going to look at solving equations that involve fractions. Okay, so suppose that you're given an equation that looks like this, 5 over 6 times x equals 10, and I want to spend a little bit of time explaining what this means, right? Because a lot of students get confused with this. Now the x is written kind of in the middle of the fraction number 5 over 6. And so what this means is just 5 over 6 times x over 1. That's what this means, okay? So multiplying straight across, we get 5 times x is 5x, 6 times 1 is 6. So when you see something that looks like this, that means this, and vice versa, right? These two things mean the same thing. 5 over 6x is the same thing as 5x over 6. Means the same exact thing, okay? So with that in mind, one way that we can deal with this is we can rewrite this as 5 with the x on top over 6 is equal to 10 and solve that way. So the first thing we want to do is undo the thing that's furthest away from x, which is division by 6. And to undo division by 6, I can multiply both sides by 6, so that clears out. Okay. Then I'm left with 5 times x equals 10 times 6, which is 60. Divide both sides by 5 to get x alone, and I get x is equal to 15. Oh, no, I don't. 60 divided by 5 is 12. There we go. Don't know my multiplication tables. Okay. So that's one way to do it. The other way to think about it is more efficient. So the more efficient way, if we think about it like this. So if we have 5 over 6x equals 10, so we start from the beginning of the problem, something that we can do so that we don't have to do the division and then the multiplication is we can do it in one step. And what I mean by that is we can multiply both sides by the reciprocal. So more efficient, we multiply both sides by the reciprocal. This is, or the flip of the fraction, right? So 5 over 6, if I flip it, it's 6 over 5. So if I multiply both sides by 6 over 5, this clears, right? Why does it clear? Well, it becomes 1, because 6 over 5 times 5 over 6, if you divide out the diagonals, 6 goes into 6 once, 6 goes into 6 once, 5 goes into itself once, 5 goes into itself once, multiply straight across, you get 1, okay? So this basically clears to 1x. We don't have to write the 1 in the front. You can if you want. But we get 1x is equal to 10 times 6 over 5. So 10, because it's by itself, is understood to be over a 1. I can simplify on the diagonals before multiplying straight across. So the 10 and the 5 have a greatest common factor of 5. So 5 goes into itself once, 5 goes into 10 twice. Multiplying straight across, 2 times 6 is 12, 1 times 1 is 1, and that gives me an answer of 12. So x is equal to 12. Now, we can always check. Remember, we can always check when we have an equation. Our original equation was 5 over 6, x equals 10. Now, I claim that x is equal to 12. So if I plug in 12 into my original equation, I get 5 over 6 times 12. Does that equal 10? Well, yeah, because when I multiply by 12, I'm multiplying by 12 over 1. I can simplify on the diagonals by 6. 6 goes into itself once. 6 goes into 12 2 times. Multiply straight across to get 5 times 2 over 1 times 1, which is indeed 10 over 1, which is 10. Okay, so that's how you can check yourself. So this was a long explanation of something easy to do, but I'm giving you the long explanation so that it makes sense for you when you start to do this on your own. If you just remember some random steps like, oh yeah, multiply both sides by the reciprocal, and you don't know why we're doing that, why? Because it cancels to 1, well, then, when we go on further, you're gonna forget that step. So anyway, that was the logic behind it. So now I'm going to start actually doing it without all of those cumbersome steps. All right, let's look at number 1. We have 3/4 times x equals 6. So remember, our efficient way to get rid of 3/4 is, to not multiply both sides by 4 and divide by 3. Let's do it all in one go. Let's multiply both sides by 4/3. Right? Let's multiply both sides by 4/3 in one go. And that way, this clears to 1, so you're just left with x on the left side. And 6 times 4/3, well, 6 is a whole number, right? So 6/1 times 4/3, I can't cross simplify on that diagonal, but I can over here. 3 goes into itself once, and 3 goes into 6 twice. Multiplying straight across, 2 times 4 is 8, 1 times 1 is 1, 8/1 is 8, okay? I didn't write the over 1, but hopefully you guys are seeing from now on that I don't have to write that 1. We can just write 8. Also, as I'm going through these problems, you should check your solution. Just get in the habit of doing it, because the nice thing about this section is that you can always see if you're right by plugging in your answer into the original equation, okay? And if you're not right, well, see where you went wrong. That's easier said than done, but... Okay, here we have 1/2x equals 10. Let's get rid of this 1/2 in one go by multiplying both sides by its reciprocal, which is 2/1. So these clear to 1, and I'm left with x, which is the goal. I wanted x by itself, 1x. And 10 times 2/1, well, 10/1 times 2/1 is 20/1, which is just 20. So that's my answer. It is true that 1/2 of 20 is equal to 10. So our original equation is satisfied. All right, let's do the next one. 4/3 x equals 20. So I need to get rid of the fourth multiplication by 4/3. And to do that, I'm going to do it in one swift go by multiplying both sides by its reciprocal. Now, students, this is what I see. I've been teaching for over 10 years, this stuff, and this is what I see a lot, okay? So I'll see a student do this. I'll see them say, okay, well, I gotta multiply both sides by 4/3, right, to get rid of it. Does that actually get rid of it and make it clear to 1? Does it? No, because if I multiply straight across, I get 16/9x equals 20 times 4/3. It didn't clear it like we wanted to. So you want to multiply by the reciprocal. That's the whole point of this. All right, so let's go ahead and clean this up. So this goes to 1, right? 1x. So 1x, I'm not writing the 1. And 20 times 3/4 is 20/1 times 3/4. I can cross simplify on the diagonal here. 4 goes into itself once, and it goes into 25 times. Multiply straight across to get 15/1, which is just 15. Again, check yourself to make sure, check with the original equation that this makes a true equation. Now look at this. You guys know how to solve this. I want to show you a different perspective in solving this, though, right? Because typically what you would do is you would say, okay, I'm going to divide both sides by 8 to get x by itself. And that's exactly correct. That's what you're doing. But what I want to show you is that dividing by 8 is the same thing as multiplying. Oops. I can't spell either. is the same thing as multiplying by 1/8. Same exact thing. Right? Just like dividing by 1/2 is the same thing as multiplying by 2/1. Just like dividing by 3/4 is the same thing as multiplying by 4/3. Dividing by 8 is the same thing as multiplying by 1 over 8. So just see that it works out the same, right? Because on the left side, 1 over 8 times 8. Well, 8 is 8 over 1. That all clears to 1x. On the right side, 64 over 1 times 1 over 8 cross simplifies. 8 goes into itself once, 8 goes into 64 8 times, multiply straight across to get 8 over 1, which is 8. So this is just a different perspective of looking at how to solve this. I mean, when you see this, obviously you shouldn't you shouldn't even introduce a fraction. That would be really weird. But I just wanted to show you the concept, like why that, multiplying by the reciprocal is the same thing as dividing by 8. In this case, 8. Okay, so anyway, so let's do some examples like this. Our first example, we're trying to solve for x. 2x minus 3 all over 8 equals 10. So I'm going to start by drawing my line through the equal sign to show that the left and the right side are separate and they need to stay balanced. Whatever I do to one side, I have to do the other. Now on the left side, I'm going to get rid of these stars too. On the left side, the furthest, so we have some operations. We have multiplication by 2, subtraction by 3, and division by 8. And the furthest thing from x is division by 8. So we're going to start by getting rid of that first. And plus, we don't like to deal with fractions if we can help it. So the first thing I'm going to do is I'm going to multiply both sides by 8. And I don't have to write the 1, so I'm not going to. What you should see here is that these clear. You don't want to distribute, right? Because we're not multiplying by 8 over 8, we're multiplying by 8 over 1. If we were multiplying by 8 over 8, we would be multiplying both sides by 1, and that wouldn't get us anywhere. So, those clear, and on the left, I'm left with 2x minus 3, no denominator, which is awesome, equals 10 times 8, which is 80. Excellent. Now, on the left, what's happening is multiplication by 2, subtraction by 3. The furthest thing from x is subtraction by 3, so I want to get rid of it by undoing subtraction by 3. What's the opposite of subtraction of 3? It's addition by 3. So I'm going to go ahead and do that to both sides to give me 2x is equal to 83. Finally, I'll divide both sides by 2, and this is not going to reduce, so I just get x is equal to 83 over 2. And that is my answer. Again, you can always check yourself, and especially since you guys are still practicing this new skill, or, if you haven't seen this in a while, if high school has been a while for you, it's always good to go to your original equation, plug in that answer, and see if you get a true solution. Just until you get used to doing this. Okay, so let's go to the next one. So we have 3t, our variable's t this time. 3t minus 1 over 4 equals 2t minus 5. So we don't have any parentheses to get rid of. We don't have any like terms on the same side to combine. I do see a fraction, which is annoying. I don't like a fraction. So on the left side, I want to get rid of that division by 4 by multiplying both sides by 4. And this is what I'll see students do. I'll see them do 8t minus 5. Is that right? Well, no, you multiplied the whole side by 4. You didn't just multiply 2t by 4. So don't do that. Don't do the amateur mistake. Although if you do, it's okay. You're still learning. But we want to multiply everybody by 4, not just one thing, right? So on the left side, those 4's clear. That was the point of that. And I'm left with 3t minus 1 on the left equals, now on the right side, I need to distribute that 4. I better distribute that 4 to everybody. So 4 times 2t is 8t. 4 times negative 5 is negative 20. Okay. At this point, I see that I have t's on both sides. So I want to go ahead and move them all to one side. So on the left side, I see that I have a positive 3t. So addition by 3t can be undone with subtraction by 3t to move those all to one side. That goes to 0t, and I'm left with negative 1 on the left side. On the right side, 8t minus 3t is 5t. Okay, so now I have that. I want to go ahead and get that t alone. So looking at the right side, I want to undo subtraction of 20 by adding 20 to both sides. And I'm going to have to write over here because I'm out of room. Negative 1 plus 20 is going to give me 19 on the left, and I have 5t on the right. Finally, I can divide both sides by 5 to get my answer. So t is equal to 19 over 5, and you should check this. Okay, let's go on to our last problem here. Now, I do see parentheses that I can get rid of from the get-go, so I'm going to go ahead and do that first. Draw my line through the equal sign. So the 4 is just going to chill there for a second. Now on top, 2 times y is 2y. 2 times negative 1 is negative 2. I just wanted to get rid of the parentheses to not deal with it. Okay, so I simplified, didn't add anything on to the right, so that's where I'm at now. Now, I want to get rid of the division by 8, so I can multiply both sides by 8 to clear that, okay? On the left side, 8 times 4 is going to give me 32. On the right side, I have 2y minus 2. What I can do from here on the right side, again, the goal hasn't changed at all for solving equations. We're trying to get that variable alone, but we have to use the rules of the game correctly to do that, right? I mean, you can't just get the variable alone by doing whatever you want. You have to use the rules of math and arithmetic to get there. So the rules of math say on the right side, if I add 2 to both sides, that keeps the scale balanced. And that's what I want to do to get rid of the negative 2, because negative 2 plus 2 is 0. And I get 2y on the right equals 32, and 2 make 34 on the left. Finally, I can divide both sides by 2 to get y alone. And I get y is equal to, let's see, half of 30 is 15, half of 4 is 2, so that's 17. 15 and 2 makes 17. Cool. So again, check your solution with the original equation. Make sure that's right. All right, let's do some other fraction examples here. All right, so we have an equation. And I have teachers that are going to be watching this and maybe screaming at me and saying, "What are you doing?" Right? Because how this is typically taught is with something called a butterfly method. And I'm going to show you that after I show you the logical way of doing it. The butterfly method's the shorter way, but are you going to remember the butterfly method? The logic's not going to fail you. The logic is the same. Get the variable by itself by doing the same thing to both sides. That's what the logic is. So, now I don't like a variable in a denominator. I don't like that. So what I'm going to do is I want to get rid of that, right? Because I want y equals something. I don't want 1 over y equals something. I don't want 16 over y equals something. No. I want y equals something. So the first thing I'm going to do is I'm going to multiply both sides by y to get rid of that. I can do that, right? There's no problem with doing that. So what I'm left with on the left is y times 4 over 3. Actually, I'm going to rewrite it. I have y times 4 over 3 is equal to 16. Now remember what we can do. On the left, I have multiplication by 4/3 to get rid of. But remember what you can do is you can do this all in one swoop and cancel this out by multiplying both sides by its reciprocal. Right? That'll cancel it out to 1. So that clears. On the right side, so I'm left with y on the left, equals, on the right side, cross-simplifying these terms right here, 4 goes into itself once, 4 goes into 16 4 times, multiply straight across to give me 12 over 1, which is 12. Okay, so your math teacher might have taught you this. And I'm not against the butterfly method. I use the butterfly method because I'm a lazy person, but it's only because I have this logic ingrained in my head. You know, if this helps you, like, do it like this, then you should do it like this, but the logic will never fail, right? How we did that. So this is the butterfly method. You basically just make a butterfly, multiply these, and set it equal to multiply these. Okay, so 4 times y is 4y equals 3 times 16 is, what's 3 times 16? 32 and 16 is 48. Yeah, there we go. Again, can't do my times tables today. I don't know why. Okay, 4y equals 48, so we can divide both sides by 4 to get our answer of 12. That's exactly what we got up here. So, if you want to do the butterfly method, go for it. I'm going to try to stay away from it, though, just so you guys can see what's going on. I know it's easier, so if you want to do it, you can, but I just want to make sure you guys know the concept. Okay, so let's move on. We did that. Now let's do the next problem. Again, I see this thing that I don't like. I don't like a variable in the denominator. It makes me uncomfortable. I don't know. It's weird. We don't like variables in the denominator. Can't really explain why, but we don't like a variable in the denominator. Maybe you'll see why later on when you take college algebra, why that's uncomfortable. Anyway, we want to get rid of it. So, how do I get rid of division by x plus 5? Well, just like getting rid of division by 5, you're going to multiply by that thing. So, if we were dividing by 5, we would multiply by 5. If we were dividing by 20, we would multiply by 20. We're dividing by x plus 5, so I'm going to multiply by x plus 5. Doesn't matter that x plus 5 is a weird thing. It's still, the logic works out the same because something divided by itself is 1. That clears out. So we're left with 8 on the left equals, all right, let's be careful here. Look what we have. We have 6 over 7 times x plus 5 over 1. Okay? Now, on top, we need to distribute because we're not just multiplying the x plus, we're not just multiplying the x by 6. We're multiplying 6 by x, and we're also multiplying 6 by positive 5. So 6 times x is 6x, 6 times positive 5 is positive 30, and on the bottom, 7 times 1 is going to give us 7. Okay? Multiplying both sides by 7 to get rid of division by 7, I get, that clears. And now I have to write up here because I'm running out of room. 7 times 8 is 56 on the left, equals 6x plus 30 on the right. Now on the right side, I want to get rid of addition of 30 by subtracting 30 from both sides. That clears. Now 56 minus 30 is going to give me, I swear, y'all, I can't do arithmetic today. I don't know what's going on. It's like I'm having like a brain log, like a glitch or something, but 56 minus 30 is not 20, it's 26. There we go. I don't know, you guys ever get like that where you're just not on your game with arithmetic? Okay, so 26 equals 6x. Let's go ahead and divide both sides by 6 to get x alone. And so we get x is equal to, I can simplify this, right? They're both even numbers on top and bottom. So if I divide top and bottom by 2, half of 26 is 13, and half of 6 is 3. And that can't be simplified anymore, so that is my answer. So a neat trick so this is just a side neat trick. If you want to divide things by 2 in your head, such as 26, so what you do is you say, well, you break it up into the tens and ones, so you say half of 20 plus half of 6. Half of 6. So half of 20 is 10, and half of 6, and now I'm running out of room, but let me erase some of this stuff. So half of 6 is 3. So 10 plus 3 is 13. That's how you can do it. So like if you have a big number, like, I don't know, 272. So half of 200 plus half of 70, or just half of 72, it doesn't matter, plus half of 2. So half of 200 is 100. Half of 70 is 35. Half of 2 is 1. So 135, 136. That's how you do it. Pretty neat. Anyway, that was a side note. Can also divide by 4 like that, right? Because you're taking halves of halves when you divide by 4. Half of a half. So like for example, 20 divided by 4 is half of 20 and then half of 10. Right, so half of 20 is 10, half of 10 is 5. So that's how you would do that. Half of 20 is just take half of 20, then you take whatever you get for that, which is 10, and then you take half of that to get a fourth of it. Okay, enough with the monkey business. Let's get back to solving equations. So we have this guy. I see something I don't like, a variable in the denominator. I'm going to multiply both sides by that denominator to clear it, right? Because this is just a number. This is that same number. The logic is that when we divide a number by itself, it clears to 1, okay? And whatever I do to one side, I better do the other side. So now, on the left side, I have to distribute this 5 in. So 5 times u is 5u, 5 times negative 5 is negative 25, over, on the bottom, 1 times 2 is 2. All right, so I'm going to write it over here because, once again, I have not given myself enough room. So since I'm trying to solve for u, I want to undo division by 2. And to do that, I can multiply both sides by 2 to clear that. So I'm left with 5u minus 25 equals 15 times 2, which is 30. Now, on the left, I want u by itself, so I'm going to first start by adding 25 to both sides. And I get 5 times u is equal to 55. Finally, I get a nice answer. Let's divide both sides by 5 to get u alone. And I get u is equal to 11. Again, you can always check yourself to make sure that that is the correct answer. Okay. Okay, I don't see a variable in the denominator, so that's good. But I do see annoying fractions that I need to get rid of. Now on the left side, what I can do, and it doesn't matter how you do it, you just have to follow the rules of the game, okay? If I want to multiply both sides by 3 over 4, I can do that. There's no rule that says I can't do it. As long as I do the same thing to both sides, I am golden, right? But you want to do things that make sense, that are efficient. There's inefficient ways to solve equations, right? So what I want to do is the goal is to get y by itself, not under a fraction bar, but I want to get y by itself. So I look to the left where y is, and I say, okay, well, to get y by itself, I can first make that y get closer to being by itself by multiplying both sides by that 2, right? So that's going to clear. Now I have y minus 4 is equal to 4 over 3 times 2 over 1 is 8 over 3, okay? And all I have to do on the left side is add 4 to both sides. Now, you can use your calculator for this, but if we use common denominators, I'm not going to go over how to do this because we've already covered this a lot in previous videos, but the common denominator is 3. So 4 is the same thing as 12 over 3. And if I add 12 and 8, I get 20 all over 3. Okay, so that is my y value there. Okay, let's see. Where are we at? Okay, what if we have something like this? How would you go about solving this? So think for a moment. How would you go about solving this? What would you do? So here's the idea. Wouldn't it be nice if we could get rid of both fractions at the same time? Wouldn't that be great? We can do it. How do we do it? Well, to do this, I'm going to write this as a note. To do this, we find the least common multiple of the denominators. So the least common multiple is usually abbreviated LCM. And this is going to really make your life easier once you get proficient in finding the least common multiple. Because fractions are a pain, let's be real. So, how do I find the least common multiple? Well, I think it's going to be easier to just show you rather than explaining how to do it. So, let's just find multiples of these numbers first. How about multiples of, what are we looking for multiples of? 4 and also 5, because those are the denominators. We're trying to get rid of them all in one swoop, okay? And to do that, we're going to find the least common multiple, and then you'll see what to do. So let's talk about multiples of 4. Okay, multiples of 4. 4 times 1 is the first one. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24, etc. Okay, those are multiples of 4. What about multiples of 5? Multiples of 5, we have 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 5 times 6 is 30. 5 times 7 is 35, etc. So these are all multiples of 5. Now the least common multiple is the smallest multiple between them. So if we look at this list and compare to this list, what's the smallest number that is shared between those? Well, it's going to be 20. Right? That's the smallest number that is shared between them. So therefore, the least common multiple is 20. That's the trick. That is the trick. We're going to multiply both sides of the equation by 20. Doing this is going to get rid of the fractions all in one step. So let's actually do this, okay? So here is what we have. We found the least common multiple is 20, and so what I'm going to do is I'm going to multiply both sides by 20, okay? Now, okay, so if I multiply this by 20, when I cross divide, when I cross cancel, 4 goes into itself once, it goes into 20 5 times. So 20 times x over 4 is just 5 times x, which is 5x. You see how I got rid of the denominator by multiplying 20 times x over 4, right? So that goes to 1, that goes to 5, multiply straight across to get 5x. All right, so I have to distribute this 20 to, so that was a separate problem. I have to also distribute the 20 to negative 3. 20 times negative 3 is negative 60. So look on the left, no more fraction. Awesome. On the right, no more fraction, because 20 times x over 5, if I cross simplify, 5 goes into itself once, 5 goes into 20 4 times, 4 times x is 4x. So that was what we did. We found the least common multiple between the denominators, and then we multiplied both sides by that number to clear the fractions at the same time, okay? Now we want to get x by itself, so I'm going to move my x's all to one side. And I'm going to do that by first subtracting 5x from both sides because it's a positive 5x. And then I get negative 60 on the left. 4x minus 5x is negative 1x. Divide both sides by negative 1 to get x alone. And a negative divided by a negative is a positive. So this x is going to be positive 60. Again, you can check yourself to see that that is indeed correct. All right, let's do some more practice with the least common multiple. So least common multiple, we are looking at denominators. Now we have 3 denominators. Now we have 4, 20, and 5. So let's list out multiples of 4. We have 4, 8, 12, 16. Maybe you guys can see what it's going to be, etc. For 20, we have 20, 40, 60, etc. Right? We're just doing 20 times 1, 20 times 2, 20 times 3. Those are multiples of 20. For 5, we have 5, 10, 15, 20, and then we stop because we notice that 20 is the smallest number in all 3 of these lists. So my least common multiple is 20. That's what I'm going to multiply both sides of this equation by to get rid of the fractions simultaneously. Okay. Now, 20 times v over 4. Let's do it off to the side. 20 times v over 4. That's the first distribution. So 4 goes into itself once. It goes into 25 times. 5 times v is 5v. So this becomes a 5v. And then we have 20 times negative 13 over 20. Now on the diagonals, 20 goes into itself once. Multiply straight across to get negative 13 over 1, or simply negative 13. Goodbye fractions. On the right side of the equal sign, we have, we can cross divide right here. 5 goes into itself once. 5 goes into 24 times. 4 times v over 1 is 4v. Okay. Now I want to collect my v's on one side. So I'm going to start by undoing this positive v, this positive 5v, by subtracting 5v from both sides. And doing that on the left gives me negative 13. And on the right, 4v minus 5v is negative 1v. Okay, finally, I can divide both sides by negative 1. And I get that v is equal to positive 13. And that is my solution. Okay, let's do the next one. So we have some denominators here that we can find the least common multiple of. We have 6, 8, and, well, 6 again. All we need is 6 and 8, really, because we have 2 6s, so let's just maybe do that one in green, too. So 6 and 8 is the least common multiple. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30, etc. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. And I stop because I found the smallest common number between them. That's the least common multiple. So that's what I'm going to multiply both sides by to get rid of the fractions. All in one go. All in one go. So 24 times w over 6 is going to be 24w over 6, which is 4w. Right? Do this off to the side if you want the practice there. 24, so 24, let me just actually show you just so you can see. 24 times w over 6 On the diagonal, 6 goes into itself once, 6 goes into 4 times, 4 times w is 4w. Then we have the second term to distribute. We have w over 8 times 24, or 24 times w over 8. And 8 goes into itself once, and 8 goes into 24 3 times, multiply straight across to get a positive 3w. So the left side's done. And then the right side, we have 7 over 6 times 24 over 1. 6 goes into itself once, and 6 goes into 24 4 times, multiply straight across to give me 28. 7 times 4 is 28. All right, on the left, I can combine like terms, so a 4w and a 3w make a 7w, so I'll just write that down there. And finally, what I can do is I can get w by itself by dividing both sides by 7. So that clears to 1, and I'm left with w is equal to 4. That's my final answer. All right, let's do one with u. So let's see. So, again, I'm going to draw this line through there. I'm trying to find the least common multiple between 6, 2, and 12. Okay, for my 6's. 6 times 1 is 6, 6 times 2 is 12, 18, etc. 2, I have 2, 4, 6, 8, etc. 12, I have 12, and I stop, right? Because, I should have listed it out here. Let's see, 2, 4, 6, 8, 10, 12, sorry. But anyway, all of these have 12 as the smallest. So that's my least common multiple is 12. So I'll multiply both sides by 12. Okay, on the left side, 12u all over 6 is a 2u, okay? Then we have 12 times negative 3u over 2. Let's do that off to the side. 12 times negative 3u all over 2. On the diagonal, 2 goes into itself once, and 2 goes into 12 6 times. Multiply straight across, and you get 6 times negative 3u is negative 18u. Okay, so this is negative 18u. So the left side is done when, we're done getting rid of fractions on the left side. On the right side, these guys cross divide to 1, and we're just left with u. Now I want to collect my u terms. So I'm going to start by subtracting 2u from both sides. And on the left side, I'm left with negative. Oh, actually, I should have combined like terms. That would have probably been better. Fine. Let's combine these. So 2 of something minus 18 of something, right? They're like terms because they both have the same variable u. They both have the same exponent 1, so I can combine them. 2 minus 18 is negative 16u equals u. And let's see. If I add 16u to both sides, that clears to 0 on the left side. And so what I have is I have 0 on the left equals 1u plus 16u. It's going to give me 17u on the right. And finally, I can divide both sides by 17. Okay, so 0 divided by anything is 0 except for 0, but we'll talk about that later. So u is equal to 0. Okay. All right, let's do one more here. So we have a denominator of 5 and a denominator of 3. So I'm going to list out my multiples. So 5, we have 5, 10, 15, 20, etc. And for 3, we have 3, 6, 9, 12, 15. And we stop because we can see that our smallest number on the list is 15. Now, if you use a multiple that's not the least common multiple, if it's a common multiple but it's not least common, you're still going to clear the fractions. You just might have to do some simplifying at the end. Okay. So, we're going to multiply both sides of this equation by 15. So let's go ahead and do that. Multiplying both sides by 15. 15 over 1 specifically. So on the left side, we need to distribute. So 15y all over 5 when we multiply. So 15y all over 5 is going to be 3y. And then 15 times 4 is going to be 60. So this is plus 60. On the right side, when I cross divide out common divisors, 3 goes into itself once, 3 goes into 15 5 times. Multiply straight across to give me 5y over 1, which is just 5y. Okay. Now I want to collect my y's on one side, so I'm going to look to the left and say, okay, well, I'm going to move this guy over by subtracting 3y from both sides. And I'm left with 60 is equal to 5y minus 3y is going to give me 2y. Finally, I'll divide both sides by 2. Half of 60 is 30. So y is equal to 30, and that is my answer. Okay, let's do a few more. So it's looking like it's, it looks super complicated, but again, to get it to be less complicated amounts to getting rid of the fractions. And getting rid of the fractions amounts to finding the least common multiple of the denominators. So we have 8 and 4. So my multiples of 8. 8. Actually, let's do multiples of 4 first. It's probably a better idea if you do multiples of your smaller number first. So we have 4, 8, 12, etc. For 8, we have 8, and then we don't have to do the etc. because we found it. So the least common multiple that we're going to multiply both sides by is 8. So let me go ahead and multiply both sides by 8. So what happens here is the 8's just cancel out, and you're just left with 7u plus 5. Over here, okay, so I can write this off to the side. We have 8 over 1 times 3u plus 5 over 4. Now, if you look on the diagonal, 4 goes into itself once, and 4 goes into 8 twice. So we have 2 times 3u plus 5, right? I have to distribute that 2 in there, right, because it's 2 times everything. So 2 times 3u is 6u. 2 times 5 is positive 10. So this just becomes positive 6u plus 10. So that was the left side. And then on the right side, 10 times 8 is just 80. Okay. Now on the left side, I have some like terms to combine. I have some constant terms, and I have some variable terms with u. So for the u's, 7u and 6u make 13u, and 5 and 10 make 15. Okay. So on the left side, to get u by itself, I'm going to subtract 15 from both sides first. And so I get 13 times u is equal to 65. Divide both sides by 13, and I get 5. So we get, so u is equal to 5. Okay, let's do another one. I encourage you to pause the video, see if you can do this by yourself. So I have denominators 2 and 8. And you should check that the least common multiple between 2 and 8 is 8. Okay, I'm going to multiply both sides by 8 because it's the least common multiple. And on the left side, these cross simplify. So 2 goes into itself once, 2 goes into 8 4 times, And I have to remember to distribute the 4 to everybody. So on the left, 4 times w is 4w. 4 times 7 is positive 28. So that's the left. On the right, I have to distribute the 8 to the 1 and also to the 9w minus 5 over 8. But when I do 9w minus 5 over 8 times 8, these 8's cancel. And I'm just left with 9w minus 5 plus 8 times 1, which is 8. Okay. Now that the fractions are gone, I want to combine like terms, collect my w's on one side. So first thing I notice is that I can combine these negative 5 and positive 8 to a positive 3. So I didn't add 3 to both sides, I just made this look different, so the scale is still balanced. Okay. Now I want to collect my w's, so I'm going to start by subtracting 4w from both sides. And so I get 28 on the left equals 5w plus 3 on the right. Okay. I'm going to go ahead and subtract 3 from both sides to give me 25 is equal to 5w. Finally, dividing both sides by 5 gives me w equals 5. Okay. Let's do one more example. And I am going to check myself on this one just to remind you guys how to check yourself. You can do it with all of these problems, but it would take way too long for me to do all of that with every single problem. So I'm just picking select problems to show you. You should especially do this with problems that you're not sure about. Like if you're like, oh, I don't know if I got this one right. Check yourself. When you check yourself, you'll always be able to tell if you got it right. Okay. So here I have two denominators. I have a 4 and an 8, and the least common multiple between 4 and 8 is 8. You should verify this, okay? What I want to do is I want to multiply both sides by the least common multiple, which happens to be 8. On the left, that's easy. 8 times 4 is 32. On the right, I need to distribute that 8 to both of these. Now here, the 8's going to clear because the diagonals go to 1. So this is just negative. Now this is where you need to be careful, okay? Very careful. Since I have a negative sign, you want to be careful that that negative is taking, is on the outside of 3w minus 5. Even though there's no parentheses there, it's implied to be there, okay? So you just want to be super careful with that. We're not just subtracting 3w, right? We're subtracting 3w minus 5, so it's very important that you make sure your parentheses are there so that the signs are correct. Okay, so that was distributing 8 to this one. Distributing 8 to the other one, 4 goes into itself once, it goes into 8 twice. I'll do it over here so you guys can see how that works. So on the diagonal, 4 goes into itself once, it goes into 8 twice. Then I need to distribute, I'm multiplying on top, so I need to multiply the 2 by everybody in there. So 2 times 8w is 16w, and 2 times negative 7 is negative 14. All right, so this is 16w, negative 14. All right, being super careful with my signs, because there's nothing more frustrating than getting to the end of a hard problem and being like, oh shoot, like I made a stupid little sign error. I'm going to first get rid of the parentheses by distributing that negative 1 in there. And so I get 16w minus 14. When I distribute the negative 1, I get negative 3w and I positive 5, right? Negative 1 times negative 5 is positive 5. Still have 32 on the left. Okay, combining like terms. On the right, I have these that can be combined, and I have these that can be combined. So 16w minus 3w is a 13w. Negative 14 plus 5 is negative 9. Okay. Now I'm going to add 9 to both sides to try to get that w alone. And on the left, 32 and 9 make 41 equals 13W on the right. Finally, I'll divide both sides by 13. To get W equals 41 over 13, which can't be simplified. Now I'm going to check this one, because there were a lot of little nuances that we had. So we want to make sure that we did it right. So I'm going to check, does W really equal 41 over 13? And to do that, I go to my original equation. My original equation was 4 equals 8W minus 7 over 4 minus 3W minus 5 over 8. And I'm just going to plug in 41 over 13 in for W. Okay, so this isn't the prettiest thing to deal with, but if I multiply 8 over 1 times 41 over 13, let's see, I know it's not pretty, but it's just going to have to do. I get 328 over 13 minus 7 all over 4 minus... Then I do this, so 3 times 41 is 123 over 13 minus 5 all over 8. Okay. I'm using my calculator, to be honest here, because I don't feel like finding common denominators. So you can as well. Desmos is a great calculator. If you Google Desmos calculator, it's going to give you a nice one where you can put all this stuff in pretty easily. Okay. All right, so we have 237 over 13 divided by 4. I get 237 over 52. So we have 4 equals 237 over 52, which I just found just by putting it in the calculator. And then 58 over 13 divided by 8 is 29 over 52. Oops. 29 over 52. So when I do this subtraction, I get 208 over 52. I know this was a lot of work to check it, but if you're really dedicated, you can see that 208 over 52 is indeed equal to 4. But yeah, that's how you can check it. Again, you can use Desmos and just literally put your answer in like that. So let me show you how to do this. Actually, let me go ahead and write this down so I know exactly what to do. This is what I'm gonna put in a Desmos, this line right here. Okay, so let me see. For later on, So we got that over 4 minus 3, just so you don't have to do so much work. Okay, let's put this in Desmos. So if I Google Desmos graphing calculator, so it's going to look something like this when I Google Desmos graphing calculator and click on the first link. So I'm just going to punch in what I said I was going to. So I have 8 and then parentheses. Now, to do a fraction, you can just, I'm trying to type in 41 over 13. I can literally just do 41 and then hit the division sign and then 13 to get my fraction. Okay, so then I close the parenthesis. I want to do minus 7, but I want to do this all divided by 4, so I want to make sure to either highlight everything or use the fraction, I want to either highlight everything here. I don't have a cursor to work with, but instead of highlighting it, I'm going to put the whole thing, the whole shebang in parentheses to say that this is the top. This is the, yeah, there you go. So there's the top. Okay, so this is the top. And then I'm going to do the division bar again with the division sign right next to the 9. I don't have a cursor to point, but that little division bar. And this is going to be over 4 minus, okay, and then I'm going to do 3 parentheses 41, little division sign by the 9, 13, close the parentheses, minus 5, but I want this to all be in parentheses with the exception of the minus. The minus is just kind of staying out there. So this is all in parentheses. And then this is going to be all divided by 8. So division symbol by the 9 over 8. And look, I get 4. All of that mess for 4. So anyway, that is how you can use Desmos to make your life easier. Okay. All right, guys. Well, thanks for watching. I know this is one of the things that students struggle with a lot, but once you practice and really get your hands dirty with this, it becomes a lot easier. So thanks for watching. I'll see you guys next time.